vectors. So we have point A, point B, show that OA equals OB. So point A, from here there is no K, so the K component is 0, so that's just 2 minus 1, 0. And the B is the I, or the X component, is 0, so 0, 1, minus 2. So to show that OA equals OB, this means the lengths OA equals OB. So to find the lengths or the magnitude, we use this formula here. So we square the 2 and the minus 1 and the 0, and then we add everything, and then we take the square root. We have the magnitude or the length OA. Same thing with OB, we get root 5. They are the same, so therefore they have the same length. And now for the angle AOB. So we use this MF19 dot product formula. If we rearrange, cos theta equals A dot B divided by magnitude of A, magnitude of B. And remember that when we use this formula, make sure the factors are from the same point. This is the angle we're looking for. So the arrow is supposed to be in this direction. Okay, so to find the angle, we use OA and OB. Previously we know the factors and we know the magnitudes. And to find the dot product, so this is called dot product. To do the dot product, just follow the MF19 formula. So basically we multiply the corresponding components, 2 with 0, minus 1 with 1, 0 with minus 2. We multiply and add everything. Use a calculator, we get minus 1 over 5. Now minus 1 over 5 is actually cos theta, not theta. So we need to do inverse cos, and we get the final answer. The midpoint of AB is M. The point P is on the line through O and M, such that PA is to OA is root 7 is to 1. So previously we know OA, we know OB, and we can just draw a simple diagram. Let's say this point is A, this point is B, and M is the midpoint, so exactly in the middle between A and B. So to find the coordinates of M, just use the average of 2 and 0. 2 plus 0 divided by 1, we get 1. Minus 1 plus 1 divided by 2, we get 0. And 0 plus minus 2 divided by 2, minus 1. So exactly in the middle between A and B. So this is the midpoint. And the line through O and M. So for the line through O and M, this is the equation. We can use a point factor, a point on the line, and the direction factor. So for the point on the line, we can use point O or point M. Of course, it's simpler to use point O because that's the origin. It's just 0, 0, 0. And for the line direction, we can use OM or MO. So here we are using OM, which is the coordinates of M, which is 1, 0, minus 1. So in simple form, the factor equation of the line through O and M is just this. Okay, now we're drawing another sketch here. Let's say this is the line. The black line is the line through O and M. And P is on this line, so this is the point P. We don't know the coordinates, so we're just gonna call it X, Y, Z. This point is on the line, and this is, let's say, point O. This is, let's say, point A. Now we know that the ratio of the distances, so PA is to OA. Actually it's PA is to OA. Alright, not OP actually. Yeah, okay, so actually this is the ratio of, yes, so let's say OA is around here. Let's say it's supposed to be shorter. Okay, so let's say this is OA. So the ratio PA is to OA is root 7 is to 1 from the previous part. Okay, so what is PA? PA is the coordinates of A minus the coordinates of P. So this is the coordinates of A minus the coordinates of P. OA is the coordinates of A minus the coordinates of O, or simply just the coordinates of A. So we subtract 2 minus x, and minus 1 minus y, 0 minus z, that's the factor PA. And to find the magnitude, we do the square root of and so on. So square root of 2 minus x squared, minus 1 minus y squared, 0 minus z squared, we have the magnitudes. But since we have three unknowns here, x, y, z, it's just easier if we use lambda. So since this x, y, z, because this point is on the line, whenever we want, we can replace this x with lambda times 1. You can replace the y with lambda times 0, which is 0, and the z with lambda times minus 1, which is minus lambda. Okay, so since the point is on the line, it satisfies the line equation. You can replace the x, y, z with this. So that's what we do here. So the magnitude of this, we've done this before, it's just root 5, and we multiply both sides by root 5, we get root 35 on the right. And now we replace the x and the y and the z with the lambda. Okay, so now we have only one unknown. We can square both sides, and then we open up the brackets. So this is 4 minus 4 lambda plus lambda squared. This is just 1, and this is just lambda squared, and lambda squared plus lambda squared is 2 lambda squared. 4 plus 1 is 5, and then we subtract both sides by 35. 5 minus 35 is minus 30. Okay, so we have a simple quadratic. We can simplify further by dividing by 2. We get lambda squared minus 2 lambda minus 15, which can be factorized into x minus lambda x plus 3, which means lambda can be 5, lambda can be minus 3. If the lambda is 5, we plug into the line equation again. We know the lambda, we multiply, we get this or this. So we have two possible positions of P. Alright, I'll see you again next time.